So we're going to take a look at Chapter 9, Section 6. We're going to take a look at the learning objectives, which is going to be using trigonometric ratios. So there's a lot of this video that you may want to go back and pause and or rewatch because trig can be a pretty dense topic. So we're going to study the very basics of trigonometry, and trigonometry basically means angle measurement. So it's a study of angles. The biggest restriction we're going to work on with this is that all triangles have to be right triangles. So for the purpose of this lesson, we are going to assume that everything is a right triangle. In this section, we're also going to use the capital letters to stand for an angle and the lowercase letters to stand for the side across from it. And letter C will always be the right angle that we're going to show with a box. So we need to define the trigonometric ratios. In the trigonometric ratios, sine is the length of the side opposite angle A and the length of the hypotenuse, which is across from angle C. Cosine is going to be the length of the adjacent to angle A, which in that image from above would be the B side of things. And it's also going to be C from the length of the hypotenuse. Now tangent is a little bit interesting because tangent is going to be not involving the hypotenuse, but the opposite and the adjacent. And those are all the measures of the legs, not the angles. So for this triangle, we want to try and find sine B, cosine B, and tangent B. If it's been a while since you've had a trig course, you might not remember the Pythagorean theorem. So to find the hypotenuse, you would do the legs squared added together. So 4 squared plus 3 squared is 25. And then you would take the square root of that. Once we get that it's 5, we don't need to put plus or minus 5, so we just get that it's 5. Then we can find the ratios. So the hypotenuse is 5, and from my image, sine B, this would be the leg opposite B, would be 4. Cosine B, the adjacent leg is 3, and the hypotenuse is 5, so we get 3/5. And then tangent B is your opposite over your adjacent. So it's really important that you know you're located at B, because if you don't know that you're located at B and you think maybe I'm located over here at angle A, then 3 is opposite and 4 is adjacent. So if you misdetermine your starting point, it's going to mess the entire problem up. Here's another example with trig ratios and similar triangles. So how can I tell that these two triangles are similar by more than just looking at them? So looking at them and saying they look similar is not a valid way to do this. Since 2 of the angles are equal, all of the angles must be equal because the third angle is found the same way. If 2 triangles have all congruent angles, they are similar. And then if I look at the sine of 30 in each triangle, so I'm here at 30, 3 is opposite, 6 is hypotenuse. So we get 3 divided by 6, or 1/2. 6 is opposite, 12 is hypotenuse, 6 over 12 reduces to 1/2. So it should make sense that if the triangles are similar, so are their trigonometric ratios. The same thing will happen for any right triangle with a 30-degree angle because that third angle has to be equal. If I want to find the side of a triangle using tangent, I have to know at least one side and one angle. So if you look at the figure, I have one side and one angle. I'm now going to set up the trigonometric ratio. So tangent of 30, how do I know that it's 30? Because angle A is 30, and so there's no other angle value. So we're at 30, and I need to have the opposite leg, which is little a, over what I know in the adjacent leg. So I get tangent 30 equals A over 200. Now this is where your previous life with a calculator is helpful. To solve this, I would multiply both sides by 200 so that I get that A is equal to 200 tan 30. So you will need to use your calculator and type in 200 times tangent 30 degrees. You can use any calculator to do this, but make sure it's in degree mode. To find the side of a triangle using cosine, so this time we're going to use cosine. I am at the 72 degree angle because that's the angle they gave me. Cosine uses the adjacent and the hypotenuse. So when I set up my ratio, I have cosine of 72 equals the adjacent leg, which was 24, divided by my hypotenuse. Now this time, I have to multiply both sides by c, but that still doesn't get me to an answer. So I'm going to have to do 24 divided by cosine of 72 to actually get my answer. Now, how do I use trig inverse functions? This is digging pretty far back. What would I need to do in order to solve something like x squared equals 20? I would need to square root both sides because the square root undoes the exponent. In that function, I need something that undoes the sine function. And what undoes the sine function is the the sine inverse function, or a trigonometric inverse. We use these when we're solving for an angle. So the minute a question says find an angle, you are using an inverse trig function. So if I have the information I know here is that I know my hypotenuse, I know the side B, and they want me to find the measure of angle B. So if I'm at angle B, I know the opposite and I know the hypotenuse. So that means I'm going to use sine. So the sine of B would be my opposite, 24, divided by my hypotenuse, 25. I'm going to type in my calculator sine inverse, which is the sine button with the -1 above it, 24 divided by 25, and then I'm going to hit enter. And that's going to give me 73.74 degrees as long as you are in degree mode. Now, these are often used in word problems. So the safety label on a 12-foot ladder says the ladder should not be placed at an angle steeper than 65 degrees with the ground. What is the closest safe distance between the base of the ladder and the wall? It's really important to draw this out. Also, anything that is above the ground is considered a 90-degree angle. So I have to choose the right formula. So if I go back to the diagram, I know the hypotenuse, and I know angle A is 65. And it wants to know the distance from the base to the wall, which is little b. So that would be my adjacent and my hypotenuse, which is why I chose cosine. Now to solve for this, I'm going to multiply both sides by 12, and I get 5.07 feet. So that's a great way of looking at how to do this problem. Angles of elevation are looking up. So if something is looking up, so if you're on the ground and you're looking at an airplane or the top of a tree or a light pole or the roof of a house, those are all going to be angles of elevation. An angle of depression is looking down. So if I'm on my balcony and I'm looking down, the angle that my head is tilted at is the angle of the depression. So it's from here to the ground. So whatever your object is, it has to be lower than you. In this word problem, the first step is to draw the image, because if you don't draw the image, it's not going to make sense. Now, what's interesting about this image is that there's a 6-foot gap between the ground and the angle because the person is 6 feet tall. And so once you see that in the image, it does make it a bit easier. So we're going to use the tangent because I'm looking for little a, and I know the adjacent and the angle. So I need my opposite, I know my adjacent, and I know the angle. So I'm going to do tangent of 32 equals my a over 200. So I multiply both sides by 200, and I get 125 feet. Most of your students will say, cool, I'm done. Except you're not done, because they have to add 6 feet onto that. So the building's actually 131 feet tall. To find an angle of depression, this is really similar. You have to draw the image. So if you read through this example and then you go look at the image, we can see that the angle of depression is up here. It's not within the blue, it's actually up here. So that means that I need to subtract 90 to find the angle of depression. So I'm going to do 90 minus that. So I'm going to do 90 minus this angle would give me what the angle of depression is. So first I got to figure out what is angle B. That's the starting point. Well, I have my adjacent leg and my hypotenuse. So I'm going to get 22 over 72. I'm going to have to take the cosine inverse because I'm looking for an angle, and I find that the angle is 72.2. Now I'm still not done because it's an angle of depression, and in every angle of depression problem, you're going to have to take the angle and subtract it from 90 because the actual angle of depression is not the angle inside the triangle, it's the angle between that horizontal line and where the triangle starts.